the eyes are gone, so it makes it nicer here. Let's see what we have. I don't know if other people do it like I do it. This is just the way I do it. I line them up under like terms. All right, we're going to go x to the fourth down to constants. 2x to the fourth. Negative 4x cubed. And positive 10x squared. Move over to the negative 1x. Negative 1 times this is negative x cubed. I'm just going to put it under. Times this, we get positive 2x squared. And times this here, we get negative 5x. And finally here, negative 3x squared. Positive 6x. And negative 15. Yeah, I'll be right back. 12 minus 3 is 9. Plus x minus 15. You don't have to do this. Is just my little way. I find it easier to just put them like that underneath each other. You can just make one big long line and then go find your like terms. That is the correct answer, by the way. Okay. What's the problem with this one? I'll tell you all this is being careful. That's all this is being careful. And not making a sign there. This one here was the tougher one. He was nice. They said that he's letting you use your calculator to find your zeros. Some teachers aren't so nice and you have to start plugging in. If you're stuck with that non-calculator, just start with the littlest numbers first and cross your fingers hoping they come out. And when you get one, divide it out, and then that'll make that back number smaller and might let you eliminate other possibilities. Okay, let's see if we got these all right here. 1, 2, 3, 5, 6. Okay, see, let you get away with this one? I would.
I don't think why not.
Instead of making you put the positive and negative on each one. Okay, they're all correct. The roots. Negative 1, 2. Negative 3 halves, and where's your, you were supposed to get two imaginary roots too, correct?
Factor it out with the tricks.
He wants to, if you want just rational roots, this is it. If you want all roots, or if they want real roots, that's it. If they want all roots, you have to do this one.
Yeah, when it says write a complete linear factorization, that means that you factor it out. Otherwise,
So then it would be
So, what are we going to get here? 2x squared
positive.
will equal negative 10. X squared will equal negative 5. So that negative will give you your I.
So plus or minus 5.
Yeah.
should you always put the I in front of the square root?
That's usually common practice. Mainly because sometimes people think they can't have trouble seeing if the I is part of the radicand. Is technically, if you stop that line behind that, that I would be correct. A lot of people get sloppy when they're doing a radical and they don't extend the line properly and they're actually meaning it's not underneath. But it's pretty common to put it up front like that. All right, so this one here then would be
X plus the square root of 5i and x minus.
at x minus, right? X plus I square root of 5 and x minus I square root of 5. Okay? And that's the way he gave his answers also. One other thing to notice is what goes into both of these. You a lot of times will bring that 2 out front. Okay? Because that 2 runs into this. When you have your fraction here, you're going to have this one here is going to have a number that's going to come out. Because you've got all whole coefficients here. Alright, so it's going to work out like that. So if I factored this 2 out, and then I would have x squared plus 5, that'll give you the same answer here. But that 2 in front, when you times that, what does that give you? 2 times x, and the 2's cancel, plus 3. So you got this, 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 and this. It's going to happen every time you get that fraction. There'll be that number here. What will happen sometimes on some problems, you might have 2 fractions, a halves and a thirds. They'll pop out. All right, if that's the case, probably there'll be a 6 in here. The 6 will come out front, which you can split 2 times 3 and run the 2 into the one with the halves and run the 3 into the one with the thirds. All right? And the reason why do you not have to take the 2 times all of them? That's what people were tempted to do all the time, right? Why not? It's all multiplied.
There's only one.
All right? You do that when you're distributing when it's plus and minus. If you have 1 plus, well, I'll put it with x's because that's what you're used to. You times it out. But even if I had 2 plus 3 plus 4 times 7, you would have to times them all. 14 plus 21 plus 28, although you could add them all up and times them, obviously. All right? But you have this. You don't take the 2 times the 3. Okay? You choose it any way you want. That 7 could go to either or because of communicating and associative principles. So you would. That's why we choose to put the 2 with the halves. Because it can go to any one of them, not all of them. So if you broke it up a 2 and a 3 and you had a third, you could run the 2 with the one with the halves and the 3 with the one with the thirds. But that's, you don't take 7 times 2 and 7 times 3. So that's the principle here, because these are times. Times, 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 times. It's this idea. Okay? And this one here. I didn't get the smiley face. The first 2 classes put the smiley face inside the 0, I guess is, I don't know, that's some teacher, they said Miss O'Donnell does that. That's correct. If you get a 0 remainder, that means this is a root. Do we have to test the 1 plus 2i? No, because if 1 minus 2i is a root, 1 plus 2i is a root. You don't have to test. Everybody okay? All right, this is all we have to do for this class. Your test will be Monday, but if there's any final questions, I mean, which was your toughest problem here? This was the one that was more room for probably mistakes.
2 to 4.
4 times before.
2, you have to be real careful on this. This is my technique for not messing up. I don't put the slash down through the minus sign to turn it to a plus. I don't do that because I want to make sure that I've changed the signs. And that way, when I see above every one of them, there's been a different, and I circle it. That's just my technique. I know now to use the circled numbers, and I know that I have changed them because of the minus. Because really, when you're collecting like terms, that's addition. You've changed that subtraction to addition when you flip the signs, and then you're adding just like combining like term. Just be careful on this one, and I guess know the two forms. Okay? And everyone knows the little rules behind this?
Yeah.
I can answer any of your questions.